Today we're going to be talking about section 4.4, which is on graphing sine and cosine functions. So before we start graphing them, we need to know what the graph of sine and cosine functions look like. Some important information would be this. For a sine function, our domain is all real numbers. Our range goes from -1 to 1, crosses the y-axis at 0, and crosses the x-axis at all values of pi, 1 pi, 2 pi, 3 pi, and so on and so forth. It's continuous, it's symmetrical among the origin, its maximum occurs at pi over 2 plus 2 times some number of pi. We'll talk about the period of the function in just a moment. And its minimum of -1 occurs at 3 pi over 2 plus a period, so on and so forth. There is no end behavior because the sine function goes on forever. And you'll see that the oscillation goes on between -1 and 1. Here's what it looks like right here. Okay, and you'll see that the period repeats itself every 2 pi. That's why we see 2 pi in there. Cosine functions are similar. They are, again, continuous throughout the entire graph. Their range, again, is from -1 to 1. Its y-intercept is actually at 1, and its x-intercepts are at pi over 2. It's continuous. It's symmetrical among the y-axis. Its maximum is 1 at pi, 2 pi, and every value after that. Its minimum is at pi and every period after that. Again, there is no end behavior because a cosine graph, like a sine graph, goes on forever. And the graph looks like this, starting at 1 right here at the y-axis, and again ending at 1 at 2 pi. Period is the same, just looks a little bit different. Now the important word we have here is called sinusoidal. Sinusoidal means it's essentially a sine function and it's a graph, and any transformation among that is similar. These are what the equation of sine and cosine look like. You may want to write that down. And A, B, C, and D are all constants, and A and B cannot be 0. Alright, so let's look at some important information before we start graphing. So if you look right here, this is kind of what a sine function looks like. You'll see that the blue is our regular sine function. The red is 2 times the sine of x, and then green is a half sine times the sine of x. And you'll see that it changes just a little bit. That change is known as the amplitude. And the amplitude, right here, you can see it's not the whole way across, it's about half of it. So from the very top point, the maximum, to halfway through, that's the amplitude. And the amplitude also goes from that halfway point, which has a special name, we'll find that out in just a minute, and the bottom, which is also the same amplitude. So the amplitude actually from maximum to minimum is twice the amplitude. So let's look at these two graphs right here. It says to describe how the graphs of f of x being sine of x and g of x being 1/4 sine of x are related. Then find the amplitude of g of x and sketch 2 periods of both functions on the same coordinate axes. So what I'm going to do is I'm going to make a table for both. Okay. So f of x is sine of x. And so what I'm going to do is I'm going to make my table. Okay. So x. So the important numbers to know in a sine graph are going to be this. 0. We said the maximum was at pi over 2. And goes through pi, 3 pi over 2, and 2 pi. Right? So, you can do it a couple different ways. One, you can look at your unit circle to figure out the values of my y. Otherwise, you can go into a calculator and do the same thing. Make sure you're in radians, because we are dealing with pi over 2, pi, 3 pi over 2, and 2 pi. So sine of 0 is going to be 0. Sine of pi over 2 is 1. Sine of pi is 0 again. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi is 0 again. And that's actually, we talked about the period. 2 pi is where it repeats itself. Okay? Now, let's look at g of x. And we said g of x is 1/4 the sine of x. Okay? I make my table. And I'm going to use the exact same values for x. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to figure out what our y values are. Okay, so if I put this into my calculator, 1/4 times the sine of 0, I again am going to get 0. Pi over 2, I put it into my calculator, and I would get 1/4. 1/4 sine of pi would be 0 again. 1/4 sine of 3 pi over 2 would be negative 1/4. And then 1/4 sine of 2 pi is where it starts repeating itself. We're back at 0 again. So, they want us to find the amplitude of g of x. So the amplitude, if I'm going to graph this, okay, this can be 1, this can be negative 1, and this is 0. Okay? Pi over 2, pi, 3 pi over 2, 2 pi. Okay? So, let's graph f of x first, and that was in green. So, 0, sine of pi over 2 is 1, 0, negative 1, and 0. So my sine graph looks like this. Right? Now, our g of x, if we put these in, I had 0, 1/4, 0, negative 1/4, and 0. So I connect the dots, and you'll see that it's significantly more shallow. And the reason that is because our amplitude is just this amount right here. Okay, so that middle part, that middle line, called the midline, we'll talk about that later, is at 0. And my maximum amount is 1/4. It's also the same from my midline to my minimum amount, which is negative 1/4. So my amplitude is going to be equal to 1/4 of g of x. So here's kind of the same thing. You'll see that when we have our f of x is sine of x, okay, that's the red one. When it's negative, what ends up happening is it just reverses its order. Basically becomes the reflection. And that's true of any sinusoidal graph. Okay, next one. Describe how the graphs of f of x and cosine of x and g of x is negative 3 cosine of x are related. Then find the amplitude of g of x and sketch two periods of both functions on the same coordinate axis. Okay, so f of x is going to be cosine of x. So I make my table. And I'm going to use the same values again. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's find my y values. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1 again. That's where it repeats itself. g of x, now maybe you figured out what it's going to be, -3 cosine of x. What I'm going to do is my table, again, I'm going to pick the same values, 0, pi over 2, pi, 3 pi over 2, and 2 pi again. When I put in 0, I'm going to get -3, because -3 times 1 is -3. I get 0, +3 when I put in pi, 0, and then -3 again. Now the instructions tell us to find the amplitude of g of x. Well, you'll see then the difference between, we'll take the minimum and the midline 0, is going to be a difference of 3. So my amplitude for this one is going to be 3. And the same thing right here, the difference from 0 to 3 is also 3. So the amplitude remains 3 both times. Now let's graph this real quick. Now I'll draw 2 periods this time, so we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's my first period. Second is going to be 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So our f of x starts at 1. I guess I should label that. This is 1, 0, and -1. I'm also going to have 2 and then 3. For my g of x. So I start at 1, f of x is blue, 1, 0, -1, 0, and then 1. I made a full cosine period. Then it goes down to 0, -1, 0, and 1. And I can connect my dots. So you'll see it looks very similar to a sine graph, just a little bit different. Now, if I look at -3 cosine of 0, it starts at -3, then went to 0, +3, 0, -3, 0, +3, 0, and -3 again. So my purple is my g of x. So you'll see I kind of screwed up a little bit on my graph, but you kind of get the picture. So that's how we graph sine and cosine graphs.